Most Slytherin of snakes. Now, in the Harry Potter movies, at least, I believe that Nagini, nailed it, Nagini is a Burmese python as depicted. But what is the most Slytherin of snakes? That makes me think of black, which makes me think of my favorite snake. I think the most Slytherin of snakes, and its name is the Gaboon Viper. Now, what sets this awesome animal apart is that it is the heaviest viper. It's not very long, but it's a real chubby snake, and it has the longest fangs, about this long, which is ridiculous if you can see the scale of this, the longest fangs of any snake, and it can produce more venom per bite than any snake. And that venom can kill you in about 15 minutes without any medical treatment. Now, why I think of the Gaboon Viper as the most Slytherin of snakes is because of its particular structure of scales and how it camouflages itself against the forest floors of northern Africa. So you may have heard of something called Vantablack. It's supposed to be the blackest black ever created, almost as black as the void that I am constantly trapped in for most of my life. It reflects almost all, it doesn't reflect almost all of incoming light, and therefore it is black. Now, Vantablack uses an arrangement of carbon nanotubes, kind of like a little forest of nanotubes, all standing up on end like this. And when light comes into those nanotubes, the ray of light comes in and then it gets trapped in this forest. It bounces around and gets absorbed and stays in and doesn't come back out. Without light coming back out, there's no reflectivity, and so you're not seeing anything, you're just seeing black. What scientists have discovered is that the Gaboon Viper has scales that have nanoscale structures, almost like carbon nanotubes, on their scale. So if you look up a picture of these vipers, they have triangular sections of their bodies that have Vantablack-like scales. They're maybe the blackest black that is natural, and it is evolved to be a void of light. It all sounds pretty Slytherin to me. Hey, and welcome to another episode of Because Science Live, where I, noted science face Kyle, attempt to answer all of your nerdy questions live, right here in situ, in this prison I keep finding myself in of nothingness. Don't laugh at that. In this prison of nothingness that I constantly find myself in. We try to do our best taking all your comments and questions on the vlogs and turning them into larger episodes, but I like doing this to see if we can do it in real time off the top of my head. I'll try my best. Aaron, what do we got?
We've got a snake-related question from Dallas Jackson. If a basilisk-sized snake were to exist in modern times, how many calories would it need to consume per month in order to be considered thriving, and what kinds of animals would best provide that?
Wow. Sorry, Miss Jackson. I don't know the answer. I don't think we're in legal trouble with that. It's very hard to say what a megafauna-sized snake would need to sustain itself. What I will say is that because of their physiology, because of their biology, and because they are cold-blooded, snakes don't need to eat as much as you think. They are able to eat large meals and survive on single large meals for up to a month at a time or more. Large anacondas, when they eat like a deer, an entire deer, hooves and all, they can just digest that deer for weeks. And that's it. So it's hard for me to say how many calories they need, because usually when we do those kind of calculations, it has to do with animals that have a much more active metabolism than snakes. But the basilisk would have to spend a lot of time in the sun to get its body temperature up to ambient body temperature. It'd probably be pretty lazy. It would save all of its energy for short strikes. It wouldn't be very active. Probably. What's next?
Cool. Ben Barry asks, would there be a way to make a quantum tunneling device that allowed people to pass through walls? What about in a sci-fi setting?
Well, on the last episode of Because Science, we were talking about what are your chances of quantum tunneling at random through a barrier like Harry Potter's platform 9 3/4. And what I said was that it is, if you make some estimations that I don't think are that far off, is 1 over e, which is a number kind of like pi, to the 10 to the 35. And this is such a small chance that I literally cannot show you because there's not enough space in the universe for me to write all of the digits that come just before the decimal place. So how could you make a device that took this chance and made it closer to 99% or 100%? I have no idea. What we're fighting against in this situation is the mass of us. Why we don't see quantum mechanical effects at our scale, at the macro scale in general, is that we're made up of a lot of tiny particles, atoms, molecules, all doing their own thing. They're not behaving in lockstep, what scientists would call coherent. Like when waves of light, say from a laser, have the same wavelength and stuff. That's a terrible wave. Say wavelength and stuff. They are coherent. Our bodies are a collection of a lot of different particles, all doing their own thing, like I said, so it'd be hard to make an entire human coherent and get all of its particles to do exactly the same thing at the same time. In a sci-fi setting, in a Star Trekian setting, you would have to do something like, oh, Captain, I've... that sounded kind of Warfy, didn't it?
A little bit.
Captain. Hey, I'm getting pretty... Okay. Captain, I have activated the coherent compensator, and we are now able to be teleported down to the planet's surface. And then Data would be like, interesting. So you would need these sci-fi style compensators like the Heisenberg compensator that Star Trek uses to make you coherent and then to make your body, as it appears to the universe, less massive, because quantum tunneling happens when particles are very, very tiny, like electron mass, like 10 to the negative 34 kilograms. Very, very tiny and moving very, 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 very fast. So everything about the quantum world is acting against us as macro scale things. It's all acting against us if we want to quantum tunnel. It doesn't really seem like it's going to be possible anytime soon, if ever. Although you can see very cool quantum mechanical effects at our scale. A normal bar magnet, if you've ever played with one, shows you magnetism and field lines, etc., etc. And magnetism and the expression of it is a quantum mechanical effect that we can see at our scale because, in quotes, the atoms in here are coherent. Their tiny magnets are all pointed in the same direction so that the effect can scale up. And so we can see fields like this. Or you can look up something very cool called quantum locking or quantum levitation. It's when you have some magnets. Let's say we had a row of magnets down here, like a bed of magnets, and we had a superconducting material floating above it, right here. Now, superconducting materials, when they expel magnetic fields from their interiors. So here, the magnetic field lines would be expelled around this superconducting wafer. I think it's like sapphire beryllium sometimes that they use. And because of this, the magnetic fields act to keep this wafer in place in three-dimensional space. This expulsion of magnetic fields is a quantum mechanical effect that you can see in real life at our scale. Look it up on YouTube. It's really cool. And then watch one of my videos. What do we got next?
Cole Varner asks, could the Flash unravel a hurricane like he did with the tornado on the show?
Could he what?
Unravel a hurricane.
Unravel a hurricane. I've heard something like this before. The problem the problem that the Flash would have unraveling a tornado or a hurricane is that air, if you start running, air doesn't act everywhere around you if you move through it, if that makes sense. So if I were to breathe out right now and I went, there would be puffs of air coming out, and as it went further and further out, it would disperse. And the amount, what I'm actually pushing on when I just take a breath, is pretty localized. When you are running through the atmosphere, the local effect that you're producing in the air is very, like I said, localized to just around, almost just the surface of your body and not very far around. So even if the Flash is going super, super fast, the area that he's affecting isn't kilometers wide or kilometers high like a hurricane would be. So he would have to be causing a serious, I would guess that he would have to be causing such an atmospheric disturbance that he would probably destroy whatever he was also trying to save. But there's a lot of problems with what the Flash tries to do, and maybe that will be a future episode. Who knows?
Good tease.
Hey, what's next?
J.M. Pickering asks, when a massive laser weapon is fired off in comics and movies and misses, how far would that missed shot travel, and would it still be destructive?
Wow, I wonder if we'll get to this also in an upcoming episode. So lasers, unlike kinetic kill projectiles, let's just call them bullets, if you fire a bullet in space, as Mass Effect 2 will tell you, you fire a bullet in space, because there's no air resistance and no gravity wells anywhere on average, it's just going to continue forward with a constant velocity forever until it hits something or an outside force acts upon it. Now, you may assume that the same thing happens with lasers, but it's not true. Although they are coherent, they will eventually spread out over a lot of distance. They're traveling the speed of light, so they go very, very far, but they will eventually spread out. And the power that they will have, and a way to measure the destructive capability of a laser is to see how much that power is going to spread out over distance. So if you take a cross-section of this laser beam here, you can see that more of the laser beam is acting laser beam is acting on a small area. So for that power, it's more concentrated. As it gets further out, you spread the same amount of power over a larger distance or cross-section, and now you have less power hitting each square meter or whatever unit you want to use. Now, for your question, the range of a laser is going to depend exactly on how the laser is set up in terms of its power output and the lenses it uses for focusing and that kind of thing. But what you can say is that lasers do not have an infinite range. At some distance away from the firing spaceship or whatever, there is going to be a distance at which you could probably stand, and it might be warm, but it wouldn't be destructive. The corollary of this is that there is some distance that you cannot get any closer to a battleship with a laser on it. Because every single meter you approach, the intensity of the laser gets more and more and more and more and more. The inverse square law, as it dictates. So the closer you get, the more deadly it's going to be. But that range all depends on how the laser is set up. Whoa, what's next?
James or Games asks, is it possible to add plant chlorophyll to human tissue before birth or after?
No idea. As I've mentioned, I think in the last, 3 of these live shows, there are animals that have incorporated photosynthetic organisms into their tissue. I know one, it's a salamander. I think it's a yellow spotted salamander? Off the top of my head, it's a salamander, and it has incorporated photosynthetic bacteria, I believe, into its own cells, and we think it might be using that to get energy from both food and the sun. To achieve something similar in humans, I have no idea how much genetic rewriting you would have to do. I assume if it is possible, it would take many years to figure out. We're not, and with all these questions of like genetic possibilities, I think something that we always forget about is like, oh, well, yeah, we might be able to reach the technology in 10 years, but will we morally and ethically reach that technological level in 10 years? Who's to say that we will ever allow or ever consider it morally acceptable to do these kinds of experiments on people? Even if things are possible, they might not ever happen because you don't want to make photo humans. Although it sounds cooler when you say it out loud. Next question.
Azul asks, any idea how the hover ships from the Matrix fly/hover?
Well, there is no question, only Azul, right?
Sure.
It's a Ghostbusters joke.
Yes. I got it.
Hey, what I think, how I think the ships in the Matrix series are flying is a form of ion thrust, ionic wind, so to speak. So you have let's just say a pad thruster here, and what I think is going on is there's a charge differential here that charges up particles in the air. Let's make our air green. Charges up particles in the air, and because these particles in the air now have a certain charge, they are accelerated by the electric field that's happening here. And as they are accelerated past the pad or through the pad or whatever, that acceleration produces a downward thrust. There are ionocraft that use this technique to hover and fly. Although for a craft that would be much, much heavier, like the Nebuchadnezzar, the amount of electricity that you'd have to pump through something like this is almost prohibitive and impractical and deadly. That's why ionocraft never get very big. The ones that you see in like scientific demonstrations and stuff are made out of balsa wood and aluminum foil. They're incredibly light, and that is because we haven't come up with power sources that are both powerful and light. Our most powerful batteries are also powerfully heavy. So if they figure that out in the future, maybe that's how they powered all the AI that eventually destroyed them, then they could use something like ionic propulsion, but it's not exactly clear. They don't spell it out. But that would be my guess. Next question.
Hateful Jerk asks, what would be a beneficial superpower and how might it work?
Yeah, so on the new channel, we did an episode that a lot of people got mad at on why you don't want super strength. And I'm going to do more of those episodes of you don't want XYZ. But I always want to mention you don't want them because of the other things that you would have to have. And some of those other things that you would have to have, you might want. They'd be actually quite cool. One thing, I don't want to spoil anything, but one superpower that I might want is super perception. So the ability to, let's say, quote unquote, overclock your mental processes such that you can take more frames of reality in. So if you imagine yourself kind of like you're watching a movie of life, you can take in only so many frames and process them into an image that seems coherent to you. If you could process more of these images, then life would appear to slow down, kind of go into slow motion like an action movie. And we think that, for example, houseflies, they can have an image, a critical flicker fusion threshold, I think. Something like that. If you show houseflies 250 blinks of a light in rapid succession per second, 250 blinks of a light per second, they can distinguish those 250 blinks as different blinks and not one constant light. Humans can do around, depending on the experiment and what you read, 24 to 60. So now this doesn't point exactly to how fast we can perceive things, but it's kind of an indication of what might be true in our own heads. So flies can see many more frames of reality per second, so they can probably process things a lot faster, which might be why they can get out of your hand in such a easy and quick fashion. All of this is to say that if you had super perception, which is a power I don't think is ever talked about, you could extend the length of events in your mind. You could come up with the perfect reply to any question and think of the perfect, wittiest response. You'd be the most interesting person at the party. Wow, it sounds kind of sad if that's all I want, huh?
It's okay.
Man, I don't want to fly. I just want to be not lame. Don't worry, I'll take a million years to think of the perfect comeback to that insult. Billy.
All right.
Yeah, next question. I'm
All
fine.
Right. I got a hair question for you. You're going to like it. Burton926 asks, how long can you grow your hair and what would be the limitations? Seriously, would Rapunzel's hair rip itself out of her scalp?
Oh. Now, it may surprise you to know that I am not a hair expert. But your hair grows in certain phases. I do not know the names of those phases off the top of my head. But there are some checks and balances in your biology for how long your hair can grow and maintain itself in a healthy manner. So because I can't remember all of those specifics off the top of my head, I won't get into it. What I will say is I've done this math. I've done the math on how thick of a rope of hair you would need to climb up. Like how thick Rapunzel's hair rope would have to be for someone, let's say, of my mass to climb up. If you were just applying the force of your weight to the hair, how much thickness of hair would you need to take on that weight and not rip? And the value is, it's about, the cross-sectional area of that hair rope is about, this is actually generous, like this. Given the tensile strength of human hair, which is more than you think, you'd only need a hair rope that thick and it could support the average person's weight. Wait. Yeah? Confirmed. You could climb up my head. Next question.
Elliot,
is that bad?
No, it's
you know what?
fine.
Next question.
Elliot Sheedy asks, would suspended animation freeze you like in Futurama or allow you to move in your own time like the stasis pods in Red Dwarf?
People keep telling me to watch Red Dwarf. I haven't seen it. What I will say about suspended animation is that if you're frozen, you're dead. If your biological processes stop, if your brain stops, you are dead. As far as we know, everything that you are consciously is everything that's in here. If this stops, you stop. I'm sounding like a downer. But what I see is the more realistic version of suspended animation is what some animals do here on Earth. There's a wood frog that in Northern America, and when it gets to wintertime, it buries itself underneath the ground, and its blood, its blood, in its veins and arteries and such, it starts producing chemicals that are but that are like urea. It's fine. Chemicals can be used for many different things, not just pee. But what this does in the frog's blood, I think it's a wood frog, is act like antifreeze. So when the winter chill comes and the frog is buried underneath the ground, it almost freezes solid. And its biological processes slow to an absolute crawl, but they don't all stop. Now, what would normally happen is when cells are frozen, the frozenness, the ice, there you go, Kyle, the frozenness kind of grows out little spikes, like freezer burn. This is exactly what freezer burn is. The little spikes puncture cells and kill those cells off, and they turn black. That's what freezer burn is. What this antifreeze in the frog's blood serves to do is prevent these ice crystals from forming and destroying its cells. And so when the spring thaw comes around, all the ice crystals go away, its cells are fine, and its metabolism, which is just the summation of all the chemistry happening in its body, they all restart, and the frog kind of just whoop, hops back to life. That would be a more realistic version of suspended animation in my mind that still uses cold temperatures but doesn't freeze you solid, like freezing your head solid for 20 years and then trying to find a cure for decapitation. Doesn't make any sense. Next question. Got time for maybe 2 more questions.
Dan Fazer asks, is there a way that in the future we can see exactly what another person sees directly stepping into their eyes? If so, how?
I don't know. I'm aware of some neuroscience right now that is trying to piece together what people see just from imaging their brain. So we're getting better at, if you just look at the scans, fMRI, functional magnetic resonance imaging, nuclear magnetic resonance imaging. If you look at that, and if you look at the scans of their brain, you can create computer programs that can correlate that with certain kinds of images. And for very simple images, very simple shapes, you can start to just image their brain and see what they are seeing without being behind their eyes. In theory, I could see this kind of technology becoming way more advanced, and then you could scan someone's brain, and let's say you put someone in a brain scanner and you hook up that output to a visor, and then you can see what they are seeing. Or you can transmit it wirelessly, let's say. So in the super sci-fi world, you put on oh, just a second, Captain. I need to show you what I'm seeing here. It's unbelievable. And you put on a helmet, and it's a little portable MRI with an output, wireless output. And it's like, are you seeing this? And you put on your MRI, you put on just your version of the goggles, and then that output is beamed into your eyes, kind of like Geordie LaForge. And a lot of Star Trek references. And then you see what that person is seeing. Now, everything that I just said might be impossible, but extrapolating from these early experiments, it's not out of the realm of our scientific imagination, so to speak. I think we got time for one more question.
One more quickly.
Let's do it.
Child of Death asks, are droids like seen in Star Wars a possibility in the near future, and if so, how far out?
Yeah, just give one of your Echo Dot's wheels.
And those Boston Dynamic dogs?
Yeah, no, I think we're pretty close to the same thing. I think once we also think to program in emotional-like responses so that you can kind of anthropomorphize these robots a little bit, I think you will feel just like they are droids. I feel like that sometimes with my Echo Dot. Hey Alexa, tell us a joke. I hope that worked on some of you. Is that
do you like Fortnite?
I might do a video on Fortnite.
How much upper body strength do you need to parachute like they do in Fortnite Battle Royale?
Yeah, that sounds like an episode idea. You know what? Let's leave it there.
Okay.
Thank you so much for watching another edition of Because Science Live. Tried to do this to the best of my ability off the top of my head, so if I am wrong, let me know in the comments. Tried my best. But next week, new vlog, new episode, new live stream. I hope you'll join me there. You can go where you're watching now, youtube.com/BecauseScience, or you can go to facebook.com/BecauseScience, or follow me on @BecauseScience on Instagram and Twitter, and you can leave me comments, questions, and corrections, and all of that stuff. I hope everyone has a wonderful weekend, and be nice to each other, because, come on, this is all we got.